Okay, so we're going to look at some of the different rules that we have for differentiation. So the first rule we're going to look at is called the product rule. And the product rule, I suppose, is in the name. The product rule is used when we have the product of two functions, when we have two functions that are being multiplied by each other. So in this example, f of x is x plus 2 and 3x squared plus 4. And those are two expressions that are being multiplied by each other. So we would have to use a product rule to differentiate that. We could multiply out the brackets, but the product rule lets us go a little bit quicker. Now the product rule is laid out in this way in your log tables. So if you have a function y that is made up of two smaller functions u and v, then to get the derivative dy dx, that would be u dv dx plus v du dx. So this is not one that you need to learn off, it's in your log tables, but you obviously need to be able to apply it. So in applying it, we just need to identify our two functions. So we'll call one of them u, we'll call one of them v. So in this case, I'm going to say that u is 2x squared plus 1, and I'm going to say that v is 5x minus 3. Then I need to find the derivative of each of these. So let's do du dx first. That's going to be 4x. dv dx, let's just make that v a bit clearer. So dv dx is just going to be 5. Applying now my product rule is dy dx is equal to u dv dx plus v du dx. So you'll notice as well, we're never multiplying something by its own derivative. Okay, so let's fill in 2x squared plus 1 for u times dv dx, which is just 5, plus v, which is 5x minus 3, times du dx, which is 4x. And then it's just a matter of multiplying out and simplifying down as appropriate. So 10x squared plus 5 plus 20x squared minus 12x, which gives me 30x squared minus 12x plus 5 as my dy dx there. That's my derivative. And that is my end result. So just taking it step by step and applying the derivatives for each part there. So let's have a look now at an exam question. So with both of with the product rule and the quotient rule we're going to look at after, it really is just a case of here's the formula or here's the little rule that we use. Now just make sure you're following the steps each time. So in this question, again, we could multiply out beforehand or we can use the product rule. So looking at it here, we'll maybe call this u and we'll call this v. So that means that u is going to be the square root of x, which is the same as x to the power of a half. And to get the derivative of that then, we multiply by the power and reduce the power by 1. Same thing with v then. So v is x plus 2, and the derivative of v is just going to be 1. Using my product rule then, so dy dx, so I start off with u, which is x to the power of a half, times dv dx, so dv dx is here, that's just going to be 1. Oh, sorry, write in my pen there. Okay, plus, so that's u dv dx plus v, which is x plus 2 times du dx, and du dx is a half x to the power of minus a half there. So du dx coming from here. So now it's a matter again, as before, of just multiplying, simplifying. So I get a half x to the power of a half here. So that's from the x times x to the power of minus a half. So I add the powers and that gives me sort of a positive half plus x to the power of minus a half. And I can reduce that down a little bit more to get 3 over 2 x to the power of a half plus x to the power of minus a half. Okay. So that is essentially my product rule. Okay, so we've seen an example there, we've seen an exam question. It very much is a case of take the options that you have, so take the two functions, find the derivative of each of those, and then apply your rule. We're going to see it later on in some of the other videos, how that kind of relates in with some of the other derivatives we're doing, but for the minute, that's kind of the base level idea. We're going to look now at the quotient rule. So quotient rule, where product rule was for products, quotient rule is for quotients or divisions. So where we have them be fractions, so where we have two functions being divided. And in a similar way, we will call the top part u, we'll call the bottom part v, and we then apply the rule as it appears here and as it appears in your log tables. So looking at our quotient rule here, let's call the top part here u, we'll call the bottom part v. So let's just lay it out as before. So if u is x squared minus 4, then du dx is going to be, 2x. Same thing happens then with v. If I'm saying that v is 3x minus 2, then dv dx is just going to be 3. Now to find my derivative, I need to make use of my product rule. My product rule is v du dx. It's important we get these in the right order. Minus u dv dx all over v squared. So let's just kind of highlight things here so we have them sorted. So making sure that we're subbing these into the right sections then when we get that far. So we start off with v first of all. So v is 3x minus 2 times du dx, and du dx is just 2x minus u. So making sure here that we're making use of a bracket because we're going to have to multiply or distribute that negative across there. So minus x squared minus 4 dv dx, which is just 3. And it's all over v squared. So v is 3x minus 2 squared. And we generally, with these ones as well, will leave that bottom expression as it is. We would only really multiply it out if it's really going to clearly save us some work here. So multiplying all of this out, then I get 6x squared minus 4x minus 3x squared plus 12. Okay, all over 3x minus 2 all squared. And I can simplify everything down here a little bit, not an awful lot, but a little bit. And I get 3x squared minus 4x plus 12 all over 3x minus 2 all squared. Okay, and that's my end result there for my derivative. Let's have a look then at an exam question or two here. So differentiate 5x over x plus 4 with respect to x for x not equal to minus 4. Okay, so let's have a look. So we'll call this top part u, we'll call the bottom part v. So u is going to be equal to 5x, which means that du dx is going to be 5. Doing the same thing with v then. So v is x plus 4, so dv dx is going to just be 1. Applying my rule then as before, so dy dx, we start off with v. v is x plus 4. So follow your rule here for yourself. So v du dx is just 5 minus u dv dx all over v squared x plus 4 squared. That gives me 5x plus 20 minus 5x, all over x plus 4 all squared. And we can simplify that down to just give me 20 over x plus 4 all squared. So 20 over x plus 4 all squared as our end result. So same idea that we've been following the whole way along. And as I say, it's just important that you kind of lay it out properly first, that you kind of lay out the question for yourself in the correct way. And that's going to help you then to apply that rule. So looking now at the next example here. So this one's from the 2007 paper. So 2007, question 6. So same idea as before. We just need to define the top part and define the bottom part and then evaluate that derivative. So let's go. We'll call this part u, we'll call this part v, and we're just going to evaluate as before. So if u is x squared minus 1, then du dx is 2x. And if v is x squared plus 1, then dv dx actually just ends up being the same again, just 2x. Applying then my rule here, dy dx, we start with v as before in my formula. It starts with x squared plus 1 times du dx, which is 2x, minus u, which is x squared minus 1, times dv dx, which is my 2x here, and it's all over v squared, which is x squared plus 1 squared. So multiplying everything out here, I get 2x cubed plus 2x minus 2x cubed plus 2x all over x squared plus 1 squared. I'm reducing everything down there as best I can. I get 4x over x squared plus 1 squared. Okay, and I can't reduce that down any further. So that is my end result there. So same thing as we've had there with product rule and quotient rule, is it's just a matter of taking them slowly, labeling the u and the v parts there in both formulas. It's labeling the u and v properly. So for the first one, it's labeling the top part u and the bottom part, or for the first one, it's the first product u and the second function v. In this case, it's the top part u and the bottom part v. And once you've done that, then it's just a matter of applying the formulas as they appear in the log tables.